morning friends. I am Dr. G. Suresh, Associate Professor, Department of Mechanical Engineering. I am here to teach you the design of transmission systems. In the design of transmission systems, now we are going to discuss about the gearbox problem. Actually the gearbox problem comes under the 4th unit. It's in the 4th chapter. Now in the gearbox problem, we have the different set of gearbox. Before that, just I would like to conclude some of the important notification about the gearbox. What is the gearbox? The gearbox is the medium through which we can set the different set of speeds to our automobiles. Here depends upon the vehicle, we can have the number of gearboxes and number of speeds. Here I am going to teach you about the 9-speed gearbox. In the 9-speed gearbox, so in that problem, the minimum speed is given that as 180 rpm and the maximum speed is given that as 1800 rpm. Then see, these are all the two parameters has been given in the problem. Based on these two parameters, now we are in the position to find out the speed diagram and the kinematic layout. These two parts just we are going to find out of this the values which is incorporated in that question. Now in the solution part, first we have to find out the progression ratio. See, the formula to find out the progression ratio is that n max divided by n minimum equal to pi power n minus 1. The n completely replicates the number of speed. The pi, this is the value which we are supposed to find out. Then n max is nothing but the maximum RPM. Here, since the problem is being accompanied with the maximum RPM of 1800, just I am going to substitute that value over here. Then the minimum speed as well is given in the problem, that as 180 RPM. Now this 1800 has to be divided by this 180 is equal to pi power n 9 minus 1. The 9 is nothing but number of speeds. In the problem it is given that as 9. Now this progression ratio just I have to find out. Based on this calculation, I am going to find out the value of progression ratio. The progression ratio is after substituting that value in that formula, just I have found out that the progression ratio as 1.33. This is the value just I am going to find out as the progression ratio as far as this given speeds. Depends upon the speeds we can have the different set of progression ratio. Next, from the PSD data book at the page number 7.20, okay, 7.20. See, R40 series. In that R40 series, we can have the different set of the speed ratio through which we can find out our number of speeds. Then the 9-speed gearbox, since it is a 9-speed gearbox, see, in order to find out the structural formula, now I am going to divide LCM, I am going to take the LCM of this 9. See, by taking the LCM of 9, I am getting that value as 3, 3 and 1. See, based on this value, this is a very easy and a shortcut method through which we can easily find out the structural formula. Now this 3, then this is 1, then this is 3, then this 3 replicates this value. Similarly, this 3 replicates this value. See, after finding out of this, now I am going to tell you how to frame the structural formula. Clear? Now this 3, actually as far as the design procedure, this is actually called as the structural formula. This 3 is stage, then this now this one is called as P1, then this one is called as X1. Similarly, this one is called P2, this one is called as X2. Always, as far as the while calculating the different set of problems in the gearbox, this X1 always must be equal to 1. Then similarly, X2 equal to P1. This is stage, this is progression, X2 equal to P1. See, based on this, just I am going to write the structural formula as 3 into 1 and 3 into 3. At last, by multiplication both this value, I am going to get the value of 9. That replicates the value which is given in that problem as 9-speed gearbox. Then, after writing of the structural formula, then I have to look after I have to look into that calculating of the speed ratio, various set of speed ratio. The minimum speed which is given in the problem as 180, the maximum speed in that particular stage is called as 560. See, this by dividing both the numerator and denominator, I am going to get the value of 0.32. Always the minimum speed, whatever the value which we are finding out as the minimum speed, that should be greater than 0.25. By dividing both this value, I am getting that value as 0.32, so that it completely satisfies completely satisfies the value of 0.25, which is above the point, which is the 0.32 is value is above that 0.25. See, that's why just I have taken this value. Similarly, n max divided by n minimum. The n max value, just I am going to choose it as 1000 divided by 560. By dividing that, I am getting that value as 1.78, that is greater than 2. Okay. Now, the minimum values always should be greater than 0.25. The maximum values always should be lesser than value of 2. This is that proper the calculation we are supposed to find out in order to find out the ray diagram. As I said you earlier, the structural formula is 3.1 and 3.3. 3.1 and 3.3. Since it is having the 9 speeds, see, this is, now we are in the part to find out the ray diagram. How to make the ray diagram? See, since it has the 9 speeds, now I am going to make the 9 set of lines in the horizontal direction. This is first line, this is second line, this is third, 4, 5, 6, 7, 8, 9. Just I am going to make the 9 set of the lines in the horizontal direction. Since it has the 2 structures, this is actually the, you can easily see that this has the 2 structures. I am going to make the 2 set of the ladders. This is first ladder and this is the second ladder. Just I am going to split the entire ladder into 9 set of equal rows. Now I am going to assign that minimum speed value of 180 over here. Since minimum speed is given in the problem as 180, I am going to assign this value in this minimum, the bottommost corner of this horizontal line. Then this 180 has to be multiplied with the progression ratio, which we already find out in that problem as 1.33. This 180 has to be multiplied by that 1.33. The multiplication will give the value of 236. Similarly, this 236 has to be multiplied by 1.33, that gives the value of 375. Similarly, this 375 has to multiply by 1.33, it gives the value as 425. Until we get the 1800, this corresponding values has to be multiplied by 1.33. The 1.33 is progression ratio. This value has to be multiplied by progression ratio. That progression ratio just keep on has to be written over here until we get the maximum RPM of 1800. Then after finishing of this entire making of this ladder diagram, now I am going to this 3 replicates this 3 denotes the stage, then this one denotes the speed. Then similarly this 3 denotes the stage, then this 3 denotes the speed. Now this is actually the speed, 3 speeds. Now this is the, see how to make this ray diagram. First this is my first speed. Now I am going to find out 1, I am going to just number it out, 1, 2, 3. This is my first point. Similarly 1, 2, 3, this is my second point. Now I have 2 points, just 1, 2, 3. Now I have noted down 3 points since it consists of 3 stages. Since it consists of 3 speeds, I am going to find out the 3 points over here. Now this point already through that n max and n minimum formula, lesser than value of 0.25 and greater than the value of 2, we have find out this 750 is the optimum one. Now this 750 lesser than this point, just I am going to make this, now I am going to join this 750 to this 180. Similarly this 750 to this 425. Then similarly this point to this 1000. Okay, see, for this particular stage, just I have manipulated the three speeds. The first speed is 180, the second speed is 425, then the third speed is 1000. Just I have made the three speeds. Similarly, since it has three stages, now I am going to mark this is the first stage, this is the second stage, then this is the third stage. After pointing out of these three stages, now just I have to join these lines, this particular rays, to the different set of the speeds. Now I am going to plot this line to this 560, similarly this line to this 750, similarly this line to 180, this line to 1320, similarly this line to 236, this line to 375. See, just you have, before making making this of ray diagram, just you have to make sure that all the points, which is noted as the speed, has to be completely locked down with help of this points. Similarly, this actually we have find out here three stages. This is our maximum speed. This point has to be connected over here. This point has to be connected over here. This point has to be connected over here. With this, we have come to the conclusion that the ray diagram has been completely made out of this 9-speed gearbox. You see, since it consists of only two stages, just I have made this one as stage 1, then this one as stage 2. Instead of these two stages, if the problem is being accompanied with three stages, then this one more ladder has to come in this particular location. This is our complete the procedure how to make the ray diagram for the 9-speed gearbox. After completion of this, the problem is not going to end. It also continues with making of the next chapter is kinematic layout. How to make the kinematic layout? Actually, this part, you can see this structure. This is stage 1, then this stage 1. This vertical line has to be just tilted. It has to be tilted as the horizontal line. See, here you can have the three set of lines. This three set of lines has to be drawn in the horizontal direction. This three set of lines has to be drawn in the horizontal direction. Again, I will just for your understanding purpose, I will write the structural formula. Here, this is actually the active live gears. Now, since it has three, just I am going to make this three set of gears. This gears actually called as active gears or the live gears. To engage this gear, see, in order to transfer the motion which is being generated inside this gear to in this gear to this particular shaft, just I am going to make the this is active gear, this is the loose gears. See, the purpose of the loose gear is just it will transfer the motion to the second shaft. That is the purpose of this loose gears. Since it has three shafts, this is shaft 1, this is shaft 2, then this is shaft 3. This consists of three stages. Now, since this consists of three stages, I am going to make three set of gears. Similarly, the second stage consists of three gears. Just I am going to make the three set of the gears over here. Now, this three set of the gears are actually considered as active gear. In order to engage this active gears to the shaft 3, just I am going to provide the loose gears in this particular location. This 8, 10 and 11. Now I am going to number it out. How to number it out? This first gear, this is actually called as 1. This is actually called as 1. This is 2. This is 3. This is 4. This is 5. Then this is 6. Similarly, this is 7. This is 8, this is 9, this is 10, this is 11, then this is 2. See, just the numbering has to be done as per the ascending order. This is the kinematic layout. See, after finishing up this kinematic layout, now I am going to find out what is the number of tooth in this particular gear. This is actually the second stage. you can easily see that this is actually the second stage, this is actually the first stage. Now for the calculation purpose, first I am going to take this second stage. Now I am going to take the first pair. In the first pair, we can see that two set of the gears, Z11 and Z12. Then the corresponding RPM of this particular Z11 must be N12, then similarly this N11. Now I am going to assume 22 for this particular Z11. Now I am going to substitute that assumed the tooth value in this particular location. Similarly Z12 equal to N12. N12 is nothing but the minimum RPM which can be transferred from the maximum RPM. I am going to substitute this value over here. Then similarly this is the N11. This N11 is the minimum the maximum RPM for this minimum RPM. Now I am going to substitute this value over here. Then since I have assumed this Z11 is equal to 20, I am substituting all the values over here. Then based on this calculation, I am finding it out that as Z11 equal to 84. Now based on this calculation, just we have found out that Z11 and Z12. After completion of this, since the second stage of the gear has been accompanied with 3 set of the gears, we are in the position to find out the number of tooths for the 6 set of the gears. Now second pair Z9 and Z10 is the second set. Now correspondingly N10 RPM, that's N9 RPM. Then Z9 just N10, the speed of N10 is nothing but 425. Similarly N9 is 750, that means 750. Now Z9 divided by Z5, this by dividing both the values I am getting that value as 0.75. Now this Z9 is equal to Z10 into 0.57. Then similarly the distance between the accumulation of Z7 plus Z8 equal to, similarly Z9 plus Z10 is equal to 66. This is the value just we have find out in this particular location. This Z11. This Z11 just we are assumed it as 20. Similarly the Z12 we are assumed it as 84. Then accumulation of this value just I am going to substitute over here. Z7 plus Z8 equal to Z9 plus Z10. The accumulation of the value is already as I told you, this is 66. By substituting this parameter, I am getting that value as Z9 equal to 38. Similarly, now the calculation of the second pair of the gear is completely got over. Now we are in the position to find out the number of tooth in the third pair of the engagement gears. Z7 then divided by Z8 is equal to N8 divided by N7. Now the Z8, the number of the speed of the N8 is 1000. Similarly the speed of the N7 is 750. By dividing both the things, I am getting that this 1.33 for this particular this particular speed variation. Then Z7 equal to as I told you, Z7 plus Z8 equal to 104. Then I am substituting this value in this particular equation in order to find out the value of Z8. Similarly, this value I am going to substitute over here to find out the value of Z7. Now the second stage of the gears, that means the 6 set of the gear tooths have been completely found out as 45, 59, then similarly 38, 66, 38 and 66. Then after finding out all set of the parameters, now I am going to find out the number of tooth in the first stage of the engagement gears. The first pair, the first pair consists of Z5 and Z6 is equal to N6 divided by N5. The number of RPM in this N6 value, the speed is 750, similarly N5 is 1800. By dividing, see, as I told you, this value always should be assumed as 20. So we have to assume it as 20. Now we are finding out that Z6 equal to 48. Similarly, the second pair, this is the first pair of the gears, just we have to find out as Z6 equal to 48. Similarly, in the second pair of the gear, the Z3 and Z4 engage itself to just transfer the motion from the main gear to the loose gear. Then this N3 divided by N4 divided by N3. Similarly, this Z3 divided by Z4 equal to 1000 divided by 1800. Now we got the value Z3 as this combination. Again, this combination Z3, this the accumulation of the gears Z3 plus Z4 equal to Z5 plus Z6. Then the whatever the value we are found out in the earlier slide has to be substituted over here in order to find out the value of Z4. Again, the found out Z value has to be substituted over here in order to find out the value of Z3. Now, whatever the gears have been engaged for the sake of transmission the motion from one end to another end, for all set of the based on that RPM which is available in the date diagram, based on that value, just we have found out all the data of the number of gears. Then at last, the third pair. See, the third pair consists of Z1 divided by Z2 equal to N2 divided by N1. The maximum RPM is 1320 divided by the maximum RPM in that particular engaging gear is 1800. By dividing both the values, we have found out that Z1 equal to 28. Then the combination of Z1 plus Z2 equal to 68. By multiplying all the values and substituting all the values in that particular equation, I am finding out as Z2 equal to 40. Similarly, Z1 equal to 28. That's all about the problem solving methodology in the 9-speed gearbox. Thank you.